Alright guys, this is for AP Formative Assessment 1.1 for pre-calculus. I've got both versions side by side here. The first three problems are the same for both of them. So for number one, it says write each set in set builder and interval notation if possible. So for set builder, for A, got the set of all x's such that x is less than 0, or x is greater than or equal to 100, and x is an element of all real numbers. For interval notation, my first interval is when x is less than 0. So from negative infinity to 0, not including the 0, there's no equal sign. And then or means union. And then x is greater than or equal to 100. So since we're equal to there, I've got 100 in a square bracket all the way up to positive infinity. For B, we've got a series of numbers here. There's nothing between negative 0.25 and 0, nothing between 0 and 0.25, so I cannot write this one in interval notation. I can only write it in set notation. And first I have to figure out what the pattern is here. So I've got negative 0.25, I've got a 0.25 in there, so I'm thinking this is going to be one of those multiple kind of answers. So I think 0.25 is going to be the coefficient in front of it. And I think if I can recognize this as 0.25 times negative 1. The next one would be 0.25 times 0, and then 0.25 times 1, dot, dot, dot. So this is going to be the set of all n, such that what it's going to spit out is 0.25 times n. Now, what has to be true about n? It starts at negative 1, 0, 1, 2, 3, 4, 5. So it needs to be greater than or equal to negative 1. And then those numbers, negative 1, 0, 1, 2, 3, 4, 5, that means n has to be an integer. So that's it for number one. For number two, got a lot of people saying that this was a function. It is not a function. Some people said it was a linear function. Some people said it was a quadratic function. It's not really either of those. I guess you could call it a quadratic in the sense that it makes a parabola, but this one makes a sideways parabola. Notice it's not x squared, it's y squared, which means for every x I put in, I get 2 y's out of it. So it's no, because, I guess I shouldn't write because that's going to be not a complete sentence. So for every x value, there may be 2 different y values. So a lot of you guys put some numbers in there to try to justify it. You came up with something like, oh no, it's a function, or it's not a function because you got imaginary answers. That's just because the numbers you chose gave you imaginary answers. So we're really, when I'm saying justify, I'm looking for some words that would justify to me that you understand what it means to be a function, that would demonstrate to me, communicate to me that you just understand what it means to be a function. All right, so for G of T, for 3, no one got it right. Some got close to it. This is a really popular difference quotient that we get in calculus. I didn't think everybody would get all the way there, but I was hoping someone would get a little bit further than we did. It's really just evaluating a function and then boiling it down. So the first part I'm evaluating at a plus h, which means for every t in my function, I'm going to put a plus h. So 2 times a plus h squared plus 18 times a plus h minus 14. So that's just this portion here. And then subtracting off g of a, which means I'm going to plug a into the function. So this would be 2 times a squared plus 18a minus 14. All of that is over a. All right, over to the side, for those of you that can't do this in your head just yet, this would give me 2 plus a 2 times a plus h times a plus h, which is 2a squared plus ah plus h squared. And then we're going to combine our like terms. It should be 2 times a squared plus 2ah plus h squared. So that's what we have here. I'm going to go ahead and distribute out the 2 as I bring it over here. So 2 times a squared is going to be 2a squared. 2 times 2ah would be 4ah. 2 times h squared would be 2h squared. And now I'm back up here. So plus 18a plus 18h. And then distribute my negative sign. So that makes it a negative 2a squared, negative 18a, and then negative times negative makes it positive 14. All of that over h. So let's see what we can cancel out. I've got a 2a squared over here and a negative 2a squared over here, so they're going to cancel each other out. I've got an 18a and a negative 18a, so these guys will cancel each other out. And I think that's about it. Oh, nope. I made a mistake earlier because this 14 should cancel out. So up here I had 18 times a plus h. So this guy here, 18a, 18h. But then I forgot to bring down my negative 14. So this should be minus 14, and then minus 2a squared, and then plus 14 from over here. So there's a minus 14 and a minus makes it a positive 14. Sorry about that, guys. These guys cancel out as well. So then what I have after I get all of that out of there is 4ah plus 2h squared plus 18h, all divided by h. So 1h will cancel out of all of these, and I end up with 4a plus 2h plus 18. And that would be your answer. So like I said, I had one get really, really close to that, but just made a small little algebra error. All right, moving on to number 4. So this is different for each version. For this version here, I've got x squared minus 16. It's in the denominator, so it can't be 0. And since it's under a square root, it's also going to be positive. So it's got to be strictly positive. I'll add 16 to both sides. I get x squared is greater than 16. So I'm going to solve the equation x squared equals 16 by taking the square root of both sides. I saw a lot of people make it this far, which was really good. And then some of them would leave it like that and say x is equal to plus or minus 4. That's telling me that the only two numbers I can plug in here are 4, which would make it 16 minus 16, which gives me the 0 on the bottom. So those are not the ones we want. What you have to do at this point is take those two variables, or those two values, put it on a number line, and then test your intervals. So if it is less than negative 4, so say negative 5 times negative 5 would be 25 minus 16. That would give me 9. I can take the square root of 9, so that interval works. Between negative 4 and positive 4 would be 0, so let's test 0. 0 squared would be 0 minus 16. That would be negative 16 down here. I can't have the square root of a negative number. Not works. And then greater than 4, I have 5. Again, 5 squared would be 25 minus 16. That works. So in interval notation, this would be negative infinity to negative 4. So this portion. And then union with this portion from 4 to infinity. You can also write it in set notation. I did accept that, and I'll write it like that over here on this side. This is the same problem over here, we just got a different number, right? So I've got x squared minus 25 has to be greater than 0. X squared has to be greater than 25. Solving the equation, x has to be plus or minus 5. Same scenario with your number line. When you test it, you end up with the same two intervals. So putting this one into set notation, I've got the set of all x's such that x is less than negative 5 or x is greater than 5
and X is the element of all of them.